Hello, welcome back. In this short video, let us look at the derivation of the sum of the infinite geometric series defined as summation x equal to 1 to infinity x square q times q power x minus 1 is equal to, we want to prove that this is equal to 1 plus q by 1 minus q whole cube, given q is less than 1. So this is our goal. So by writing the expansion, and basically expanding the series, we have 1 plus 4 times q plus 9 times q square. By basically inserting the values of x, that is the natural numbers, in the series, we have 10q cube, 25q power 4, and so on up to infinity. Now we can basically decompose this series as 1 plus q square plus q cube and so on to infinity, plus 3q plus 8q square plus 15q cube plus 24q or 4 up to infinity. So basically we decompose this series into sum of two series. That is, the first one is the classical geometric series without any, basically with the coefficients 1, and this is a summation. This is also geometric series with the coefficients, and with the coefficients 3, 8, 15, 24 and so on. Or let us label the series 1 plus q square plus q cube, that the classical geometric series, as L0. L0 is equal to 1 plus q square plus q cube and so on. And let us label the sum of the geometric series that we are interested in as L1. So L1 is equal to L0 plus this series, that is 3q plus 8q square plus 15q cube, 24q power 4 and so on. So this can be rewritten as 3q times 1 plus q square plus q cube and so on, plus there is a 5q square left here, and there is 12q cube, and then we have 21q power 4 and so on. So this is nothing but L0. So we have L0 multiplied by 1 plus 3q plus 5q square multiplied by 1 plus q square and so on, plus we are left with 7q cube plus 16q power 4 and so on. So we can clearly see that this basically can be rewritten as L1 is equal to L0 multiplied by 1 plus 3q plus 5q square plus 7q cube plus 9q power 4 and so on. So basically the coefficients are the coefficients of this infinite geometric series are nothing but the odd natural numbers, and the coefficients of this infinite series is just 1. So basically we decompose the original series L1 as product of two infinite series, that is L0 and this series with odd natural numbers as coefficients. Now by using the definition here and also this series, we can rewrite this series of interest L1 as L0 plus, and this is nothing but summation x equal to 1 to infinity 2x minus 1 into q power x minus 1. Now we know the definitions or the values of the summations 2x times qx power minus 1, and also the second summation, that is minus 1 times qx power minus 1 and q power x minus 1. So we can actually use those definitions and insert those values here. We have L1 is equal to L0 multiplied by 2 times summation x equal to 1 to infinity x times q power x minus 1 minus summation x equal to 1 to infinity q power x minus 1. But we know that L0 is equal to 1 by 1 minus q. Therefore L1 is equal to 1 by 1 minus q times 2 times, and in a previous video we already established that this infinite series, the sum of this infinite series is nothing but 1 by 1 minus q whole square, and this is equal to 1 by 1 minus q. So finally we have L1 is equal to 1 by 1 minus q, and this, by simple algebraic manipulations, we can easily show that this is equal to 2 minus 1 plus q by 1 minus q whole. Therefore we have L1 is equal to the summation x equal to 1 to infinity x square times q power x minus 1 is equal to 1 plus q by 1 minus q whole cube. The summation of the infinite geometric series with the coefficients equal to the squares of the natural numbers is equal to 1 plus q by 1 minus q whole cube, where q is always less than 1. Thanks for watching.